Hello, my dear friend. Welcome. I am David Cortese and this is my website www.david-cortese.com. In this video, I'm going to talk about an important physics topic, the electricity. So let's start. You can find this PDF on my website. So electricity is a fundamental concept in physics, representing the flow of electric charge. It is responsible for a wide range of phenomena, from the lightning in our homes to the operation of complex machines. Understanding electricity involves exploring various concepts such as electric charge, electric fields, potential difference, also known as voltage, current, resistance, and the interplay between these elements in electric circuits. Electric charge, Q. So we write Q for the electric charge. Electric charge is a property of matter that causes it to experience a force when placed in an electric field. There are two different types of electric charge: the positive charge and the negative charge. The unit of charge is the Coulomb's T. Coulomb's law: the force F between 2-point charges Q1 and Q2 separated by a distance r is given by the formula F is equal to K times the modulus of the product between Q1 and Q2 over R squared. K, that is this constant, is 1 over 4 times pi times epsilon 0, and it is 8.988 times 10 raised to 9, and the unit is Newton times meter squared over Coulomb squared. Electric field E. The electric field is a vector field around a charged object where a force would be exerted on other charges. The electric field E at a distance r from a point charge Q is given by the formula E is equal to K times Q over R squared. The direction of the electric field is radially outward from positive charges and radially inward towards negative charges. Electric potential V. Electric potential, also known as voltage, is the potential energy per unit charge at a point in a field. The electric potential V at a distance r from a point charge Q is given by the formula V is equal to K times Q over R. The potential difference between 2 points in a circuit drives the flow of electric current. Electric current I. Electric current is the flow of electric charge per unit time. The unit of current is the ampere A, which is equal to 1 Coulomb per second. So it is Coulomb over second. I is equal to Q over T. Current can be directed DC or alternating AC, depending on whether it flows in a single direction or reverse direction periodically. Resistance R. Resistance is the opposition to the flow of current in a material. The unit of resistance is the ohm. According to the Ohm's law, the voltage V across a resistor is proportional to the current I flowing through it. V is equal to I times R. The resistance of a conductor depends on its material, length, cross-sectional area, and temperature. Ohm's law is a fundamental principle, that is basically this, that relates voltage V, current I, and resistance R in an electrical circuit. V is equal to I times R. This law applies to ohmic materials, where the resistance remains constant over a range of voltages. Ohm's second law, the resistance R of a conductor is given by the product of the resistivity ρ by the length L of the wire divided by the cross-sectional area S of the wire. So resistance is ρ times L over S. Power, that we indicate with the letter P. Electric power is the rate at which electrical energy is transferred by an electric circuit. The power consumed by a device with voltage V and current I is given by the formula P is equal to V times I. Using Ohm's law, power can also be expressed as P is equal to I squared times R, that is equal to V squared over R. The unit of power is the watt, W, where 1 watt is equal to 1 joule over 1 second. Capacitance, C. Capacitance is the ability of a system to store electric charge. So capacitance is the ability of a system to store electric charge. A capacitor is a device that stores electric potential energy in an electric field. The capacitance C is defined as C is equal to Q over V. The unit of capacitance is the farad, F, where 1 farad is 1 coulomb over 1 volt. Resistors in series. Resistors in series are connected end to end to the same current flow through each resistor. And the total resistance R thought is the sum of all resistances. So R thought is R1 plus R2 plus ... Rn. Resistors in parallel are connected across the same voltage source, and the total resistance R thought is given by the formula 1 over R thought, so the total resistance is equal to 1 over R1 plus 1 over R2 plus ... 1 over Rn. Capacitors in series. The total capacity C thought of capacitors in series is given by the formula 1 over C thought is equal to 1 over C1 plus 1 over C2 ... plus 1 over Cn. Capacitors in parallel. The total capacity C thought of capacitors in parallel is the sum of all capacities. So it is C thought is equal to C1, C2, Cn. Kirchhoff's current law, KLC, the total current entering a junction equals the total current leaving the junction. The sum I in is equal to the sum I out. Kirchhoff's voltage law, KVL, the sum of all voltages around an closed loop in a circuit equals 0. Sum V is equal to 0. So, the first exercise. A 9 volt battery is connected to a resistor of 3 ohm. Calculate the current flowing through the resistor. So, we calculate it using the Ohm's law. So we need to use this formula. V is equal to I times R, so I is equal to V over R, that is 9 volt over 3 ohm, and the solution is 3 ampere. So the current flowing through the resistor is 3 ampere. Second exercise, calculate power dissipated in a 5 ohm resistor with a current of 2 ampere flowing through it. So we calculate this using the power formula, that is P is equal to V times I, that is I squared times R. So we need to calculate 2 ampere squared times 5 ohm, that is 20 watts. So the power dissipated is 20 watts. The third exercise, 3 resistors R1 2 ohm, R2 4 ohm, R3 6 ohm are connected in series with a 12 volt battery. Calculate the total resistance, the current flowing through the circuit, and the voltage drop across each resistor. So the total resistance is the sum of of each resistance, so it is 2 plus 4 plus 6, that is 12 ohm. And to calculate the current, we use the Ohm's law. So we need to do this multiplication. It is V is equal to I times R, but we need to do this. I is equal to V over R tot, that is 20 volt over 12 volt over 12 ohm is 1 ampere. To calculate the voltage drop across each resistor, we use the Ohm's law for each resistor. So V1 I times R1 is 1 ampere times 2 ohm, that is 2 volt. V2 is I times R2, that is 1 ampere times 4 ohm, that is 4 volt. V3, it is I times R3, that is 1 ampere times 6 ohm, that is 6 volt. So the total resistance is 12 ohm, the current is 1 ampere, the voltage drops across R1, R2, R3 are 2 volt, 4 volt and 6 volt respectively. The last exercise, 2 resistors, R1 is 10 ohm and R2 is 20 ohm, are connected in parallel across a 15 volt power supply. Calculate the total resistance, the current through each resistor, and the total current supplied by the power source. So the solution is, so for calculating the total resistance, because they are connected in parallel, we need to use this formula. So it is 1 over 10 ohm plus 1 over 20 ohm, that is 3 over 20 ohm. So the total resistance is 20 over 3, that is 6.667 ohm. So to calculate the current through each resistor, we use the Ohm's law. V is equal to I1 times R1, so I1 is equal to V over R1, so 15 volt over 10 ohm is 1.5 ampere. So it is V1, it is V2. V2 is equal to I2 times R2, so no, because the volt is the same, so we need to calculate I2. So V over R2 is 15 volt over 20 ohm. That is 0.75 ampere. So the total current is I1 plus I2, 1.5 ampere plus 0.75 ampere. So it is 2.25 ampere. The total resistance is approximately 6.67 ohm. The current through R1 is 1.5 ampere, the current through R2 is 0.75 ampere. The total current supplied by the power source is 2.25 ampere. So, conclusion, electricity is a vast and essential area of studying physics with applications in almost every aspect of modern life. from understanding basic concepts such as charge, current, and voltage, to analyzing complex circuits using Ohm's law and Kirchhoff's laws, electricity forms the backbone of many technological advancements. Mastery of these concepts enables to design, analyze, and troubleshoot electrical systems, paving the way for further exploration into more advanced topics like electromagnetism and quantum electronics. So you can find this PDF on my website www.david-cortese.com, where you can find a lot of material for your studies: software engineering, web development, mathematics, physics, chemistry, and so on. You can find also a lot of games and apps and good music. So there is also a chat, so you can sign up, you can chat with me, and clicking here, make a donation. So dear friend, your donation is important, help me update this website and join this community. So thank you for watching, see you next time, bye bye.